library and get one.
Oh my god, did you guys see the storm last
Yes!
night?
No.
Yes, the lightning was like this over the house.
Oh, did it?
No, the lightning.
You took the garbage out last night?
I don't know.
I seen the lightning from a window. When I went into the house, I seen it from a window.
You saw the lightning from your window. Good.
Yes.
Kevin, take your headphones off. Stay for a
And
while.
it was like fast, like.
Helen.
And
Diana.
it was gone, and it flew over the house. It was like,
Jimena.
it flew over the house.
I did. It didn't start till Monday.
We had the wind, lightning, and I was scared last night.
You know where the free parking
It
is?
is.
In the back of the school.
And I told my mom that if I lost my Chromebook in either a fire or my house will burn down or like a tornado swept my house. I told her that if that happens, we have to pay for a new school computer.
Yeah, but you would have insurance that would cover that. Don't worry. Don't panic.
If we lost our school computer and it burned up with nothing in a house fire or like a tornado swept it, we would have to pay it out of our pocket.
After 10 minutes, can I bring this down to Miss?
Christopherson.
No. She's like blonde. What's her name? Is her? Miss Frank.
What?
After 10 minutes, can I bring this down, Miss Frank?
What is it for?
My job. Let me tell you something.
Okay, all I want to know, does she absolutely have to have it right then, or can I send you near the end of the hour?
It's actually due today.
Right, but can I send you just near the end of the hour and you give it to her?
I don't know when she's in her office, but I guess.
Okay. Yeah, you can leave it with, because isn't her office in student services?
No.
Where is it at?
It's in the career center.
You can leave it with Miss Kong. So we'll get it down there for you. Let's put it that way. Okay? We'll get it down there for you. All right.
I can't even log in. My computer's going slow.
Well, did you shut it down and turn it on again? Because that's the easiest way for me to help you. All right.
Everything sounded so much similar. So like science is starting to sound like history. It's just do we have 9 days or 11?
Just as a
You can go count.
But after the weekend.
All right, ladies and gentlemen.
That's why I didn't
That's what I meant by outside.
Okay.
He's weird.
Come on, PD. Come on, Peter. Go to custodian school.
All right, ladies and gentlemen. So here's where we're at. Tomorrow is your last day of the week, ladies and gentlemen, for school. Okay? So tomorrow is also the last day that I will accept any late and missing work, which means, again, many of you cannot, but if there were some of you who did poorly on the Unit 7 test and wanted to do a retake on it, tomorrow is the last day for it. Also, ladies and gentlemen, Tomorrow is the last day that if you are missing a lab or a lab activity that you can get it turned in, and I will still give you credit for it. Okay? Two things that I want you to completely understand. Number one, ladies and gentlemen, from what I understand right now, there is going to be no science summer school this summer for completion because there are not enough kids for it. That is the last that I had heard. But number two, even if there were, I do not give incompletes in conceptual chemistry. So you either make it and you pass the class or you don't and you fail the class. Now, most of you are doing very well. But the ones who aren't, the reason that they aren't is because you're missing things. Okay? Now, again, almost all of you have your tests, your quizzes all done. Not a problem there. The only thing that some of you are missing is your labs. And not many of you. But if you are missing a lab and you do not turn it in, and you are not passing going into the final, you will have to pass the final exam with a good grade to pass the class. If you are passing going into the final before you take the final will not move your grade from a passing grade down to a failing grade. So if you have a D going into the final exam, you have passed the class, okay? No matter how poorly you do on the final exam, I will not let it fail you. Now, it might take a grade of a B down to a C if you do poorly on it. It might take a C down to a D, but it will not take a D and make it into an F, just so that you are aware, okay? Now, we also have to do the Unit 8 test, okay, which will be next week or the week after, maybe that Monday of that final week of school. We'll review for a couple days, and then we will take our final. Your finals in here, ladies and gentlemen, are on Thursday, June 6th, 7:30 till 9, just like every trimester we have had this year. 2 days of finals, 1, 3, and 5 on the first day, 2 and 4 on the second day. Yes. That was the start of this conversation. No, you are off tomorrow, and then you are off next Monday.
Tomorrow's Thursday.
You are not off next Friday. Tomorrow is your last Friday off of the year. Okay? So you are off school on Friday of this week. I said tomorrow, but it's Friday. You are off on Monday of the next week. You will then have Tuesday through Friday next week, and then Monday through Friday the week after. But remember that Thursday and Friday are the final exam days. So you will not be here the whole time on those Thursdays and Fridays, because if you don't have a class, you don't have to be here. And if you, either way, you're going to get out earlier on both days, because after the last final, you'll be done.
On Friday, we end up at 10 something, right? Because then we have 2 classes.
We end at 10:45 on that Friday because, yes, there are only 2 finals that day.
Mr. Grant, so at my third hour, I have a study hall.
Yes.
Am I supposed to stay over? Can I just stay home? You don't have to-
Well, here's the thing about that. You do not have to go to your study hall class on the final exam day. However, you will have a final exam first hour with me. You have a class 5th hour. Then you're going to have a final exam then, but you could go home in the middle portion of the day. You just need to come back for your final exam 5th hour. Now, again, otherwise, if you have a class, you are supposed to be in class. Yes, but study halls, if you have a study hall,
Or
you
an academic
can.
lab.
What?
Or an academic lab.
That is like a study hall. Academic lab, you're going to want to check with your teacher, though.
Because the academic lab teachers basically say go to the library or the lunchroom basically for study
Okay.
hall. Basically, it's
Okay,
like a study
but
hall
again-
rule.
All I'm telling you is I cannot speak for them, so you have to check with them. Okay? Questions? All right. By the way, ladies and gentlemen, we will have a short quiz tomorrow. We will have a short quiz tomorrow. Let me think about it. You're right. Let's have the short quiz on Thursday, May 23rd, 2024, during our first period class. Better idea. Thank you very much for making me clarify that. Because tomorrow never gets here. So that would be a bad thing to say that it's tomorrow. So it will cover the basics of redox, and it will cover periodic trends, ladies and gentlemen. And it'll be a shorter version of the quiz. Won't be quite as long as what we normally have. Okay? Questions?
No.
Good. So then let's take a look at our first pair deck question. What part of a redox reaction, or the part of a redox reaction that loses electrons? Which one of those choices is the part of a redox reaction that loses electrons? Go ahead and make your selection, ladies and gentlemen. Has it been 10 minutes? Well, again, what time did class start, Kevin? No. There's a calendar on the wall right over there with the times that class starts. And if you don't know what time class starts as a junior in high school, that's kind of bad for first hour. If it's been 10 minutes after that, yes, you can go. Okay. Alexa, we've got a quiz from last week to make up. Are you ready to do it now? You can do it tomorrow. In class? That'd be fine. Okay. All right, ladies and gentlemen, let's see your choices. Show responses. All right. By the way, what does a neutral species mean? I should have probably told you this beforehand. What does a neutral species mean? What? I know. I'm hoping one of you can answer it. No. Not an extinct species.
It's a thing that's always alive.
No. In a reaction, you know how something doesn't change its charge from side to side? That's considered the neutral species. So there is something that something can get oxidized, something can get reduced, and then something cannot change its charge. Yesterday in the last reaction we showed you, hydrogen was a +1 on one side of the reaction, it was a +1 on the other. That would be considered a neutral species because it is not changing its charge. It's not becoming more positive or it's not becoming more negative. Okay, so the correct answer, ladies and gentlemen, is oxidation. Very good. Very good, very good, very good. Next question, ladies and gentlemen. The part of a redox reaction that becomes more negative. Please answer this while I go check on my test takers next door, please. And then I will be back in just a moment. Okay, how are we doing over here?
I'm just gonna guess. Anyway. No, but one of our pressures. I didn't hear my head. Just gotta make sure you keep dying. Wait till we get. We need to know if you got a concussion or something. Oh, I told you. I told you. Bro, no, why she coming in soon to me? Bro, Isaiah was something else.
Remember, conversion factor, you can either say this is equal to this,
And then there's also like,
or you can say this is equal to this.
out of place. I don't know what you're talking about.
All right. Well, if you got the last one, ladies and gentlemen, you should get this one. Okay? Hopefully those were the same two people who got the last one wrong. Because the part that becomes more negative is the reduction, ladies and gentlemen. That's what reduction means. Something goes down. What goes down? Something becomes more negative in the reaction. Okay? Which of the following is not a redox reaction? You've got 4 choices there, ladies and gentlemen. Pick which one you think is the best choice.
What's in the actual?
What?
Nothing. I was just reading the answers.
Oh, okay.
Oh yeah. I remember the bottom two, Ms. Bukowski did it to the child's dowd. It's the last two on this answer.
Miss Polkowski, what?
Did it with the kids' dolls when we had.
Oh, yeah.
She did them with the child's Barbie doll.
Yep, she did them with Barbie dolls. You're right.
The last two on the list.
Yep. All right. Of the reactions, ladies and gentlemen, and again, we didn't specifically say this when we went through them, ladies and gentlemen, but of these four reactions, the only one that is not a redox reaction is a double replacement. The reason a double displacement is not a redox reaction, it is the only one that does not involve lone elements. So we showed you how if you have a compound and a compound making a compound and a compound, the charges don't change. If it's a +2 on one side in a compound, it's going to be a +2 on the other side in a compound. If it's a -1 on one side in a compound, it's going to be a -1 on the other. Nothing changes in a double replacement reaction as far as charges goes. Synthesis, yes. Decomposition, yes. Single replacement, yes. All double replacements are not redox reactions, ladies and gentlemen. And again, a double replacement was when you have two compounds creating two new compounds. No lone elements. So nothing that has a charge of 0. Questions? All right, our last question for you then today, ladies and gentlemen, is this. Which of the following is your most important birthday? Look at the answers. Which of those birthdays do you think is the most important of those choices?
What?
I don't know.
Who of you?
Why are we bringing your birthday into this? Is my question.
Because I want to know what you think is your most important birthday. Now, what are your choices, ladies and gentlemen?
Synthesis, decomposition, single replacement, double replacement.
This doesn't make sense.
Wait, that doesn't make sense.
No. Synthesis, decomposition, single replacement, double replacement. I was like, what? I was confused. I'm not selecting.
Wait. Something went wrong there on that pear deck, ladies and gentlemen, because your choices. Sorry about this. I didn't realize that something was wrong with it.
Replacement and double replacement. I was like, what? That doesn't make sense.
Nope, that doesn't make sense. Sorry, I was wondering why you guys were so confused. What happened there? Hang on a second.
Decomposition. Do you have to log in again?
No, hang on. Okay, here were the answers that were supposed to be there. Down here. I have no idea why it put those on there. So the answers that multiple choice it was supposed to give you is your 15th birthday, your 16th birthday, your 18th birthday, or your 21st birthday. Sorry, I don't know why it gave you the wrong choices. So of those choices, ladies and gentlemen, which one is your most important birthday to you?
This year is my most important.
Nope. Those are your four choices. 15,
I
16,
know.
18, or 21. So which one?
This one's my most important because it's especially my golden birthday and it's my 18th birthday and it's my golden birthday this year.
Okay, so you're 18. Okay? What's your most important birthday of those choices? 15th, 16th, 18th, or 21st? 15th. Okay. Brianna? 21st. Alex? 18th. Okay. Helen? 21. Diana? 18. 21. Christian? 16. 18. 18,
because then you're a legal adult. Right?
Okay.
18.
18. Lucy?
21.
21. Christopher? 18. Ethan? All right. Okay, why did I pick those, by the way?
15. I
What's
know.
special about 15th?
It's quinceañera.
Okay, it is, and I put that one on there because for some people that is a very important birthday,
I
the
thought that was-
quinceañera year,
I
right?
thought when you're sweet 16, that's what they do.
Well, no, they do it on the 15th, but why did I put the 16th on there?
Sweet 16.
No, not for sweet 16th. I could care less about sweet 16th. What's important about your 16th birthday? You get your driver's license. What is important about your 18th birthday?
You're an
Legal
adult.
adult.
You're a legal adult, and technically you can also do something that you can't do earlier. Okay, you can enlist in the military. Some parents probably wish you had done that earlier, the moving out part. But the other thing at 18 that you can do in the United States,
Roll it.
you can vote.
And
vote.
you can go to
You're a legal adult, you can vote.
I can
By the
vote
way, you
in
can't buy
next
cigarettes
election.
at 18 anymore.
No, but you can
Next
go.
election.
You can go to bingo. I'm excited.
Okay, you can go to bingo.
I'm excited.
Yes, and you can go to some casinos at the age of 18 as well. Okay?
Las Vegas.
No, not in Las Vegas. You cannot go to a casino that serves alcohol at 18. You have to wait till you're 21. And that's the reason for the 21st is because
You can drink.
that's legal age to drink. Okay? So again, ladies and gentlemen, the most important birthday to you is very individual. Some people are very excited about getting a driver's license. Some people are more excited about their quinceañera. Some people are more excited about their 18th because it may be their golden birthday, or it's a birthday where you are considered technically in the eyes of the United States to be an adult. And 21 is the one where technically, well, where legally you can start drinking. Okay? Legally is the key word there, ladies and gentlemen. Okay? Yes. Which one was my favorite birthday? I would have to say either my 16th or my 21st.
Why the 16th?
Because I got to drive. To me, that was a big deal. That was a big deal when I could finally start driving. I literally, on the day I turned 16, I went, got my driver's license, and I remember being able to come home, borrow my brother's car, and go out for a drive on my own with no one in it. So it was a 1978 Monte Carlo. So the doors on that thing weighed 4,000 pounds. And when you drove it, the seat leaned back so far you were looking up at the ceiling. So it was a boat, yes. And my brother was nice enough that he would let me use his car to drive to school every day after I took him to work. So. All right. Okay, open up your EISN, ladies and gentlemen, and get to slide number 40. Now, the idea of oxidation and reduction, knowing which substance gets oxidized. Oxidation is when you're doing what? Okay, but changing how? Again, what is oxidation? No. No. You got the right answer somewhere in all that mix, but you had the words in the wrong order. What is oxidation, ladies and gentlemen? Losing electrons. Losing electrons is oxidation. So what is reduction? Gaining electrons. That part will be on your test here. I'll take that back. What?
It said 100%, but then I tried charging it, it just turned to 0.
That's unusual considering it was on the charger all night, but okay. All right. So again, I am not going to ask you, like we're going to do here, to look at a reaction and tell me which substance is oxidized and reduced yet. That will be on your test. But I am going to ask you to tell me what it means to be oxidized, what it means to be reduced, because we have been going through that over the last few days. So again, Leo the lion goes grr. Loses electrons is oxidation. Gaining electrons is reduction. The other way to remember it is the term oil rig. Oxidation is losing. Reduction is gaining. That is what I will be asking you on the quiz tomorrow. Okay? What does it mean if something is reduced? It means that it has gained electrons. What does it mean that something has oxidized? It means it has lost electrons. I will ask you about periodic trends. Now, periodic trends were what we talked about last week. In other words, as you go down the periodic table, what happens to the atomic number? As you go across the periodic table, what happens to atomic radius? As you go down the periodic table, what happens to atomic radius? Which of these elements is the better metal? Which of these elements is the better non-metal? Things like that we talked about earlier, okay? But for today, ladies and gentlemen, we're going to identify which substance is reduced and which is oxidized in the following reaction. We're also going to identify if something does not change, because that is very possible. Now, first of all, should have probably been doing this all along, but we'll do it right now. Element or compound?
Compound. Element. Compound.
What kind of reaction is this? An element and a compound producing a new element and a new compound. What? Oh. If you remember the high school dance, ladies and gentlemen, that we talked about in the first semester or first trimester of this course, there were 4 kinds of chemical reactions. There was a synthesis reaction where a boy and girl go to the dance alone, they meet up at the dance, and they start dating.
I don't remember this.
2 lone elements become a compound. Okay? Then there is a decomposition reaction that occurs. A couple goes to the dance together and they get in a big fight at the dance. They go home separately. That's decomposition. They started out as one thing, they ended up as 2 or more different things. This is a single replacement. This is a situation where you go to the dance with a date. But in the middle of the dance, your date dumps you and then goes and starts dating somebody else. That is a single replacement reaction. So this element right here, that's the person that you get dumped for. You are part of this compound. So in the end, there is a new compound with the person who was alone and part of your compound, and you're sitting here alone, not having a date anymore. That is a single replacement reaction. A double replacement reaction would be you go on a double date. You and your friend and another couple go on a date. But things aren't working out very well. So halfway through the date, you switch. You create 2 new compounds. That is a double replacement reaction. That is the 4 basic kinds of chemical reactions explained in a simple high school dance. So this would be what is called a single replacement reaction. This element right here is going to replace this one in the compound. So now this is alone and this is in the compound. Okay? Now, as always, ladies and gentlemen, we have to balance this. And to balance this, we put a 2 in front of the AgNO3. Why? Because there were 2 NO3s over here. So we put a 2 in front of that here. Now there are also 2 Ags, so I put a 2 in front there, ladies and gentlemen, and then everything is balanced. Now again, I am not going to make you balance equations on the test. But for us to have an equation and to look at it, they should always be balanced. Now, what I am going to ask you to do is identify charges. What is the charge on barium right here? Let's actually go a step back first. What is the easiest thing to identify its charge? Single ones, ones that are alone. Which ones are alone here? The BA over here and the AG over here. So start out by identifying those and putting zeros by them, because that's an easy thing to do. If it is not with something, we're going to put a 0 by it. Okay? Now, when it is with something, now we go to the periodic table. So when we go to the periodic table, what is the charge of Ag on your periodic table? And that one's not going to tell you because I had you write it on your periodic table. Does anybody have it written on their periodic table what the charge of Ag is? Thank you. It is a +1. We had you write that because silver gets used in a lot of compounds. So silver would be a +1. What's the charge of this NO3 group on the back of your periodic table? Flip it over, you'll find this NO3 group. What's the charge of that group? -1. Over here, what's the charge of Ba based on where it's at on the periodic table? What group is Ba in, ladies and gentlemen?
Oh,
It's group number 2. So what's its charge?
+2.
It's a +2. What's the charge of the NO3 here still? -1. That didn't change. So we go through and we identify all of these charges, ladies and gentlemen. 0, +1, -1. 0, +2, -1. Okay? And now what we do is we compare them from one side to the other. So here's the Ag. It starts out as a +1. It's going to become a 0. That means it is becoming more what? More negative. It is becoming more negative. Okay? We'll get to that in a minute. All right? Ba starts out at a 0 and it becomes a +2. What does that mean? It's becoming more, well, but just positive or negative for now. Which one? 0 to a +2.
Positive.
It's becoming more positive. Okay? It's becoming more positive. Okay. So always one substance becomes more negative. Okay? Now, again, be careful. 0 to a -1 is becoming more negative, correct?
Yeah.
What about +2 becoming a 0?
More negative.
That's still more negative, right? Going from +2 down to 0, that is still becoming more negative, correct? What if you go from a +4 down to a +2? You're still becoming more negative, okay? What if you go from a -1 to a -3?
Still negative.
You're still becoming more negative. All of these are becoming more negative. Okay, now, how do you become more negative? What actually happens to the atom that it becomes more negative? It has to do with electrons. What happens to it? It gains electrons. Anytime you gain electrons, ladies and gentlemen, what is that? Oxidation or reduction?
Reduction.
This is reduction. Okay? So all of these things here, ladies and gentlemen, all of these things always go together. So, if you become more negative, if you go from 0 to a negative number, and by the way, any negative number here, correct? If you go from any positive number down to 0, still becoming more negative. If you go from a positive number to a smaller positive number, you're still becoming more negative. And if you go from a negative number to a larger value for the negative number, -3 instead of -2, -4, or you become more negative, you're still becoming more negative. The only way this happens is if you gain the electrons, and that is reduction. That is the only way it can happen, ladies and gentlemen. Okay? Now, here, silver is becoming more negative. +1 down to 0. That means silver is getting reduced. Okay? Barium is becoming more what? From 0 to +2. becoming more positive. So when we're looking at charges, you will either become more negative or you will become more positive. Now, how do you become more positive? You go from 0 to a +1. That is becoming more positive, correct? You go from a negative number to 0. That is becoming more positive, correct? What if you were a +1? How can you become more positive as a +1?
+4.
You can become a +4, you can become a +2, you can become a +3, right? Okay? What if you're at a -4? How do you become more positive without going to 0? What? You can become a -3. Any way you look at these are all more positive. Okay? The exact opposite of what's going on over there, correct? Okay? So to become more positive, what does an atom have to do? Has to lose electrons. The only way you become more positive is if you lose electrons. Okay? What do we call this? Oxidation. Okay? So in other words, ladies and gentlemen, these are the two things that are happening in here. And then from there, we can figure out if it's reduction or oxidation. So silver is reduced. Why? It goes from being a +1 to a 0. Its charge is going down. Barium is oxidized. It's going from a 0 to a +2. Now, which one does nothing happen to? Which one didn't change? Well, that's the NO3. Starts out as a -1, ends up as a -1. So guess what? That's the one that neither happens to. That is how you will go about identifying oxidation and reduction in a reaction. Okay? Now, questions? Yeah, definitely. When I'm asking you what is reduced, you can give me the symbol or the name. Okay? Either one. Okay? Either one. Good question. Questions? Yes, no, maybe so. All right. So let's take a look at another reaction here, ladies and gentlemen. Okay? Aluminum plus lead oxide makes lead plus aluminum oxide. What kind of reaction? Again, a single replacement. This element here replaces lead in the compound, leaving lead alone and putting aluminum in here. Okay? That's what's happening. Okay? Now, the reason this is Al2 and O3 is because aluminum has a +3 charge, oxygen has a -2. Over here, lead has a +2 charge, oxygen has a -2. Actually, I'm sorry, lead has a +4 charge here. Okay? So now, the next thing we would do is we would balance it. Again, balancing it is just there so that we can make sure we have a balanced chemical equation, because we should always balance chemical equations. I'm not going to ask you to do this on a test. I'm not going to ask you to do this on a quiz. We did take some time a while ago to balance some, but we're not going to be doing it here. Okay? All right, but what I am going to ask you to do is tell me what the charges are. Now, which are the first two that you should do here?
AL and PV.
AL and PV, because they are what?
Single elements.
Which makes their charge?
0.
Okay, good. According to the periodic table, what's the charge of Pb when it is in a compound?
+2.
Nope. Look at what group it's in.
+4.
+4. What's the charge of oxygen in a compound?
-2.
Okay, over here, what's the charge of oxygen in the compound going to be?
-2.
And what's the charge of aluminum in a compound? Look carefully where aluminum is. It's a +3. So once we have all of these charges, ladies and gentlemen, now we can go around and we can compare. And we always compare reactant side to product. So again, let's start with lead. It goes from a +4 to a 0. That is becoming more what? More reduced or more negative. By the way, since all of these go together, that's fine. It's becoming reduced. It's gaining electrons. It's becoming more negative. I don't care how you say it, but that's what's happening there, correct? Okay, now we look at aluminum. Aluminum is going from 0 to +3. That is becoming more. No, 0 to a +3 is not more negative.
Positive.
That is more positive, which means you are doing what with the electrons? And that is oxidation. All right, one more thing in this reaction, and that is the oxygen. -2 to -2. What's happening to it? Nothing, neither. Neither one. It is not changing. Questions? Anyone need more time? Take a look at this reaction, ladies and gentlemen. See if you can figure out what is reduced, what is oxidized, and which one does neither happen to. There is one of each of these in this reaction. Go ahead and see if you can find it. Hey, peroxide.
There's nothing on it.
It does, it's just wore off on the back. These guys wore it off of there. Okay? So that should be everything you need. Thanks. All right, figure out what's oxidized, what's reduced, and what neither happens to. Yeah, and if that's the case, that's right.
Wonderful. But I can't just do it, and then all of a sudden it's like, yeah, right.
I had it like a size 7 on the Google Doc. I did a size 7 on Google Doc, and I still read it.
Well, I can read it.
That's for the final. That's for the final. Finish class. Finish class. And that's all the notes on this class on one page. On a size 7 font. And I'm highlighting the key point.
Okay, but I looked it up. I saw the same thing for CO.
What?
Which has no charge.
If you run the it's -2.
I'm confused. Hold on. This I'm confused on. I'm still confused on how to do this.
Dish out. You can't take it, bro. You don't get on that, bro. I remember when he used to come down.
Zero. Oh, zero.
I know the C I
But it's exactly.
Yes.
for the charge of CR, what is that?
Okay. Now, good question. First of all, let's get the basics down. What's the charge of CR here?
0.
Okay. Now, the charge of CR here is a little bit more difficult because we can't find it on the periodic table, right?
Right.
What is CR, metal or non-metal? What is the charge of metals always? Positive. So even if we don't know positive what, by simply knowing that it's positive, right, means that we're going from what here?
Negative.
No.
Zero.
0 to a positive number. That's enough for you to figure it out.
0 plus whatever.
Now, again, here, what is the charge of ClO3 based on your periodic table?
-1.
-1. How many of them are here?
3. 2.
2. So what would 2 negative ones give us for a charge?
3.
No.
-3.
No. 2 negative ones cannot give you 3.
Oh, -2.
They give you a -2. Now, what is the total charge on a compound always? Always. 0. Always. Okay? So what number plus a -2 equals 0? So this part has to be a +2, correct? Okay, how many of them are there? 1. So the question is, what number times 1 gives you a +2? You should be able to figure it out now. Okay? But again, simply knowing that this number was positive would be enough to still do this. Okay? Just knowing that that's got to be positive. Okay?
I don't know what sends me on my computer.
No.
You shut your computer down lately?
What is that? That's popping. It'll automatically log you out. It does that, yeah. If you don't shut down your computer, it just sleeps. Sir?
Oh, like the guy that
All right. So, Ethan, which one is reduced? Well, you're supposed to find which of these substances is reduced. Which one is reduced? Which compound? Remember, it isn't. Which one? The CR?
Is that an I or an L?
Where? This?
Yeah.
This is Cl. So ClO3 is reduced. Okay? All right. Which one was oxidized? Which one was oxidized? Mariana. What? Cr. So which one was neither? Christopher. What's that? The CO. Okay. Anybody want to argue with any of these three? Jasmine. So you're saying this should be CO. You agree with the CR, correct? But this you're saying goes over here. Okay? Anybody else? Well, which one are you disagreeing with? The original one is right? Okay. Anybody else? I'm willing to put up a third option if there's a third option that you think is correct. Okay. So how many people think the top one is correct? Raise your hands. 1, 2, 3. Okay, Anna, is that yes? 4. How many people think the bottom one is correct? Which one is correct?
It's up with it.
Really? This one?
Bottom.
So even though ClO3 goes from -1 to -1, it gets reduced.
Actually, hold on. No, because like. Okay, I think.
Cobalt goes from +2 to 0.
Is there 2 reduced ones?
No?
Okay. I'm so lost now.
Okay, well, let's look. Hang on. It shouldn't be that bad. Do we agree with these charges?
Yeah.
Okay. So is there any way that ClO3 can be reduced if its charge starts out as -1 and ends as -1?
No.
So that one has to go here, correct?
Right.
So now the question is, are these two correct? Well, for chromium to be oxidized, it would have to lose electrons and become more positive. So chromium goes from 0 to a +2. Is that becoming more positive? And that is what is oxidized. And the cobalt is going from +2 to 0. That is what's being reduced. So there you go, ladies and gentlemen. That's all of them.
I'm gonna stop second guessing myself.
Yeah, you do. By the way, which one was neither here? Not oxidized or not reduced? The ClO3. Okay, the ClO3. Now, this was our last one, ladies and gentlemen. Which one was neither here? The oxygen. Right? It was neither. Which one was neither here?
The nitrate.
What do you notice about the nitrate in this one? The NO3. The oxygen in this one. And the ClO3 in this one. Okay, they don't. But what do you notice about them in the reaction? They're all part of compounds. So if you're part of a compound on one side and part of a compound on the other, what is that going to mean? That it's going to be the one that's the neither. The ClO3 is the neither because it's in the compound on both sides. The O2, the O is the neither. Why? Because it's in the compound on both sides. The NO3 is the neither. Why? Because it's in a compound here and it's in a compound there. If you're in a compound and you stay in a compound, can you change your charge? No. So therefore, you're going to end up being the one that is neither, ladies and gentlemen. You're going to end up being the one that's neither. Now, why is that important? Well, because how many different things are here? 3, right? The Ba, the Ag, and the NO3. And if you can figure out which one is neither, Well, now all you got to do is figure out which one of the other ones is being reduced or oxidized. Becomes a lot easier. Questions? Okay, ladies and gentlemen, let's give you some time to practice. So, in Google Classroom, ladies and gentlemen, there is an identifying redox reaction worksheet, ladies and gentlemen. If you open it up, here's what it looks like. Now, I have done something here to help you, but it may seem to be confusing. Alexa, Helen, look up at me, please. The reason I have CRG here, 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 and here, and here is so that it is formatted for you so that you can go in and where it says CRG, you can erase this and you can tell me what the charge of Fe is. Okay? Why are there two here?
For those two down there.
For the hydrogen and then for the chlorine. So they're already done for you so that all you've got to do is click in this box and tell me what the charges are. The first one for the hydrogen, the second one for the chlorine. Fair enough? Same thing over here. The first one for the iron, the second one for the chlorine. Then the charge of the hydrogen. Now you can come down here, what substance is reduced? What substance is oxidized? What substance, if any, was unchanged? Okay, stop. Which one is unchanged? In this reaction, which one is unchanged? Why? It's in a compound here. It's in a compound here. That means it's going to be unchanged. Boom, you got one out of the three done. Now you just need to figure out which one is oxidized and which one is reduced. Okay? So down here again, as Jaslyn said earlier, I don't care if you write the name. I don't care if you write the symbol. But Fe, H, and Cl go in one of these three boxes, and we just told you where Cl goes. Questions? Okay, ladies and gentlemen, get to work. You got about 15 minutes or so to finish up.
So we had to fill the CLGs with the what is it?
Okay, remember Zoe, what I just said? You're going to take out this CRG, and what's the charge of iron when it's alone?
0.
Then you put the 0 in up there. That's just there so that you can easily do it without having to put in a text box and things like that. It's there for you so you can just erase where it says CRG, and you can put the charge of those things in here. So that way then you can look and say, okay, which one is becoming more negative? Which one is becoming more positive? Okay?